Good evening, everybody. Welcome to the Tuesday Evening Space Show program. I'm your host, David Livingston, and it is great to be back after having been gone for medical reasons toward the end of last week and over the weekend. And we're kicking the week off with a great guest, fresh from ISDC, who our co-host, John Jossy, will introduce in just a minute. I do have a couple of real quick announcements. Many of the people here are great sponsors for the space show. And I don't thank our sponsors often enough. But this guy who's got the center position for right now, Phil Swan out of Seattle, is a sponsor with his Atlantis project. We're very grateful, Phil, for your ongoing support. Dr. Kathari, which is right here, um, is also a great sponsor. He has Astrox, specializes in nuclear and aerospace and hypersonics and all sorts of good things. And he is a great sponsor as well. The other, and John Jossy has, I still think, the only, probably the most credible space um, settlement blog that I've come across. John, do you even have competition? I don't think you even have competition. Space Settlement Progress now. And he is really up on the field. And we really appreciate all those sponsors here. But we have other sponsors too, but these other people are all great supporters of the space show. And we would not be here without John Hunt, Marshall Martin, and Dallas Benoff. And we go back many, many decades to when there was an attempt to bring trinkets back from the soil of the moon to sell as trinket jewelry back in the early, and I guess it would be the mid days of the history of the Space Frontier Foundation, because the foundation was actually started much earlier than even that. Of course, that venture went nowhere, but Dallas and I have remained really good friends. And he's been a terrific supporter of the space show for decades, and I really appreciate that. And he's still involved in the field, which is even cooler. And then we have our two telephone guests today who are here and who are aware of, friends of, or supporters of, or who follow our guest, George Tyson. John Jossy is our co-host, and John met George, saw him, was in his track at ISDC, suggested I bring him back on the show because George was a guest June 1st, 2005, long, long time ago. So John wanted him back. We have him back. John, the program is yours as co-host. So thank you for being here.
Sure. Thank you, David. Well, George Tyson is CEO of Orbital Construction Pioneers. He is a veteran space technologist, entrepreneur, and instructor whose career has spanned NASA missions, military service, commercial spaceflight training, and more recently, pioneering work in orbital construction. His bio goes into much more detail, which is on today's show blog, but we'd rather talk to him than read about him. So, welcome to the space show, George.
Thank you for having me again. I appreciate it very, very much.
Yeah, it's going to be a good show. I was in your presentation or at ISDC. I guess it was your colleague Brian who's on the phone. Um,
Yeah, our executive vice president is one that actually gave the presentation. I was co-presenter, whatever you want to call it. I was just up there for the really tough questions.
yeah, so it, the presentation was on the company's, I guess, flagship project, First Step, which is based on additive manufacturing biological modules that can be integrated into orbital structures. So let's start there. Why don't you introduce us to this concept, which, oh, by the way, it's summarized in a PDF, which we've put on the blog. And it's also available on Orbital Construction Pioneers website, which is Orbital Construction Pioneers, all one word.com.
George, before you start, real quickly, we have two PDFs on the blog on the spaceshow.com site. for this
Yes, sir.
program under this date. That is the only place we can upload PDF documents, so it's not on Substack or YouTube or anything. So if you want to see the PDFs and his agreement that I'm sure he will tell us about in a few minutes, he's got a great, colorful, picture-oriented, very well organized PR. I call it a flyer. He calls it a cut. I don't know why it's a cut, but whatever it is, but it's informative. And if you're curious about what he's doing, this is a great visual. But go check out those two PDFs. And then there's also some URLs on the Space Show blog. Again, this date under the name George Tyson. Okay, follow on John's question to you. The microphone is yours.
Our program is called the first step. And the reason why we call it the first step is it gets us from where we're at on the ground to permanently in orbit. Basically, we are going to build a station, which we're going to call Station 520, that grows what we build with. So we've developed a additive manufacturing system that uses a biological thermoset mixed with plant material, dried plant material, which we then can extrude into panels or other things about 50 meters in diameter. So all the plant material is grown in orbit. The panels are produced in orbit, and the panels are assembled in orbit. So it's orbital manufacturing without being dependent on anything lifted, or very little to be lifted up from Earth. In a nutshell, we're going to roll. Some of the plants that we're looking at is hemp. So we say we roll, we don't smoke. We're going to roll our own, not smoking.
But if you smoked it, you could probably visualize whatever you want and claim success, right?
We're not going to go there. Yeah. You and I understand that. We're not going to go there.
Microgravity effects of smoking hemp. I mean,
oh man. But basically that's what we're looking at, is making a thermoset, essentially a bio-epoxy mixed with biomaterial, extrude it into whatever panels, whatever, and then construct large structures out of that. The Station 520, we're planning on it being about 320 meters in diameter, doing about a 1 rotation, 1 RPM. So we should get around Moon's gravity. We can make it larger, we can spin it faster, whatever. So yeah, so it'll be the first and only one to manufacture in space for space. Now, how do we get from here to there? We will lift stuff from Earth. Our framework will be lifted. The initial plants, the aquaponics, the hydroponics, that stuff will be lifted. We're looking about 7 vehicles, about the size of the Starship 3. Not saying it's going to be the Starship, but about that size. We'll put a framework in, and the vehicles will be turned into our pressurized areas for initial growth. And then we start printing the skin and skin the outside of the station until the whole thing's pressurized. And then we start filling out into the pressurized space with more and more plants, processing plants into the thermoset, etc., until we can start printing whatever for whatever customer. There will be byproducts. We will have fresh water. We will produce oxygen. We'll produce food. We will accept waste products from customers to process. And we may even have some methane to be able to sell. So we become this hub. And from this hub, you can start making other manufacturing, other stations. So now it becomes a little industrial complex up there. Everybody's specializing in their own thing, and it just grows from there. The more people we have out in orbit, the more customers we have, and the more waste product we get into process. That's it in a nutshell.
how are you funded so far?
My wallet, actually, we have a few investors. We have some friends and family that have actually believed in us as how we are currently funded. So and we're not just theory. We've actually done some experimentation. This is actually a bio epoxy, bio filler, which we drilled and tapped.
Okay, stop. What makes it a bioepoxy filler? What's biological about it?
The epoxy that this is made of is 100% plant-based.
Okay.
The filler is 100% plant-based. So we could grow everything that's in this.
Mhm.
Okay. Does it matter what plant or
Oh yeah, yeah, it does. Certain plants will give us more resin to produce the epoxy from. Certain plants give us a higher tensile strength, and that's part of the reason why we're talking about hemp. I mean, it's one of the best tensile strength and durable type plant out there. I mean, that's why rope was made and sails were made from it for many, many years. This is a failure from one of our tests. It was an impact test. You can actually see the cracks in it. You can see that there's a lot more filler in this than there was epoxy. So we've been testing different formulas, different types of epoxies, different fillers. We've tried basalt because basalt's something we can get from the moon. We believe that we can make, or somebody can make, fiberglass and fumed silica on the moon. The basic materials are there. I know they've already made glass with simulant. So we tried that as a filler. So we've tried different things that if they were mining in the moon, we could use as a filler. And that was our what we were initially looking at. And then we were like, but we're so dependent on somebody actually getting to the moon and start mining this stuff and processing it. And it's like, when will that happen? That's the reason why we stepped back, looked at how do we get from here to there. And that's how the first step came about.
What do you process on the moon, and what is the process to make the resin or whatever it is you need to make those products?
All right, we're not going to process anything unless we're going to use something from the moon as a filler. We're not going to process anything from the moon. Everything will be grown and processed on the station itself. I'm trying to remember the exact term, but basically, when you can take plant resin and you can. It's not called epoxidized. There's something else for the name for it. I'm sorry, it slips my mind. But you can turn it into a epoxy resin and an epoxy hardener, and you can mix the two together to make it into a standard epoxy hardening type stuff. But it all comes from plants. The only time we would use anything from the moon is if we had a customer that wanted to use something from the moon, or if we were going to build something on the moon, then it makes sense to actually use some of the resources that are on the moon. In other words, we would ship our epoxy to the moon, mix it with whatever regolith on the moon, and build whatever's on the moon that we're going to build for whatever customer.
Dallas, go forth, speak up.
Hey, George, I've read through the PDF on your concept, and I infer from the pictures and what I scanned, I shouldn't say read, I scanned it, that the Station 520 is a disc. Is that
Yes,
correct,
sir.
or is it a torus?
Yes, no, it's a disc and it has a gravity boom. It would be pointing toward the Earth to help stabilize it as we spin it.
Oh, so you're not living on the rim. You're living on one of the sides of the walls of the disc.
Okay, so let's see. Let's assume this is the disc that's
Right.
rounded. That's not. We would be standing on it like this because it would be rotating like this.
Oh,
So
so it
our
is
heads would
rotating.
be, our heads would be pointing toward the center as we
Yeah.
rotate.
Okay.
And then
Which
there would be
yeah,
a gravity boom that would stick out that would help stabilize the rotation and keep
right.
it from wobbling.
Okay. So that's a very different station structure than what has been conceived in the past.
I don't know. How far back do you want to go?
Why do you say that, Dallas? I mean, this is a typical, ring type
No,
rotating space
I don't
station.
recall. I recall. I mean, I've seen tori that spin, but I've not seen a disc as a station that spins.
Oh, I
Uh,
see.
Yeah.
Okay.
You are
Spinning's
correct.
not the problem. It's the difference. It's the disk concept.
Uh, Back in the dark ages, I belonged to another organization called Space Frontier Operations. We were
Hmm,
looking at permanent habitations, permanently habitation in space,
right.
and we developed a ring type station. And what I kept looking at was all that space that's being wasted.
Right.
If we could fill that all in, look at how much more pressurized area we would have and the different gravity gradients that we
Right.
would have. So you
Right.
could do all sorts of things on that station.
Yeah.
So
You're
that's the
right.
reason why we're going with a solid disk.
Yeah. I appreciate the clarification. Thank you.
Mhm.
Okay, so George, you're going to grow, I guess, hemp on the
One of the
station
one of
in
the plants,
your
yeah. Mhm.
and so how long does it take to grow enough material to make some of these large structures? Does that grow really quickly? And how does that work?
All right. So at this point, I could actually pull out my shovel and start shoveling it, or I could just say the truth, which is we don't know how long it'll take to grow the amount of material we need to print what we need to print. We know that hemp grows very fast. That's one of the advantages of hemp. Hemp works very well with a hydroponic or aquaponic type situation. In fact, the plants grow taller and stronger in an aquaponic slash hydroponic type system than they do in the ground. So we have that as advantage. We're also looking at a couple other plants. So the hemp would be the filler. Yes, you can get resin from hemp, but to do that, you have to have the hemp plants further apart because they actually have to bloom and seed to get their resin. However, there's other plants that are much better for resin, and we're looking at several different plants and how well they work in the environment we're going to have it in. But essentially, they're all ground cover plants, which means they grow like weeds because that's essentially what they are, and that's where we'll get the resin from. While the hemp will be for the structure, for the filler, that kind of stuff.
And hemp's a
So
summer plant. I mean, it grows to maturity in a 3 month period, 3 to 4 month period. So
It's a grass.
yeah.
Yeah.
So have you verified that the structures composed of this plant-derived biomaterial would be airtight?
We have done experiments. This is molded. It is not 3D printed yet. We've done some experimenting with the 3D printing. We're now in the process of building a new type of printer to get better results. But yes, it's solid. There is no airflow through it. Uh, it it um, it doesn't burn. It chars. We've tested it at different temperatures. We've done it at 122 degrees C down to minus 80 degrees C. We only went down to minus 80 degrees C because that's what our equipment can handle right now. We've impacted it with a steel ball, essentially a 1 kilogram steel ball from a meter and a half. We've shot it with a 22. We've burnt it. We've done tensile strength with dog bones. We're not there yet for the exact type of mix, but we know from what the results we're getting. By the way, when our test report is up on our website for our latest test report for this material, and you can see that we're not quite there yet, but there is a good possibility that worked just fine.
Mm-hmm.
You, I know you have first step. Do you have any kind of feasible idea of a timeline for accomplishing your objectives?
Back in our day, they used to say, no Buck Rogers without Bucks. So I say nowadays we move at the speed of money. The more funding we have, the faster we'll move. We are new. I mean, this company has only been around since it was a concept in 2004. So, wait, 2004, 2014, sorry. Um, 2000 and wait a minute, hang on. My brain's got a kicking gear. 2024, because this is 2026. Wow, we're living in the 2000s, people. So it was 2024 when we had this concept. So it's a new company. The only funding we've gotten so far is from friends and family, and I appreciate them so much. It's amazing what we've been able to do with the money we've had. We are now finally getting to the point where we're being recognized and people are starting to inquire. In fact, we just signed a deal with a company called Exo out of Hawaii, and we're going to do a joint development of a bioregenerative life support system. And I can't go into what it is. There's a lot of NDAs and all that other stuff that have been passed, but it's something brand new for us, and it's a possible income stream before we have everything running. Which leads me into the other PDF that's up there, the Interplanetary Regen Network. At ISDC, I talked to a lot of people. If you were at ISDC, chances are at one point in time, I got in your face and talked to you. What I came to realize was what we're talking about, our first step is so large that we're not going to be able to do it ourselves. I'm not Elon Musk. I'm not Jeff Bezos. I don't have more money than, whatever. I can't buy companies. We can't buy companies to do things. So we're going to need to have a group of people, a group of companies to get us in space, period. One of the ideas that fell out of ISDC was the IRN, the network, the Interplanetary Regen Network, where a group of companies come together in a consortium fashion and work toward a common goal. We just formed that. Today was the first day we put out the press release. So essentially, this is our coming out of the closet talk here. We want to there's a lot of intelligent people. In fact, I'm looking at a string on the top of my screen here of a lot of intelligent people. All of you have done various things in the space industry. Many of you still are doing many things in the space industry and are part of other companies. This is knowledge. If we all brought it together and worked together, we could actually be off planet permanently. That's what the IRN is all about. And so we all collaborate together. We go chase money together, and we fund this so that we can make it happen.
Marshall, you have a question.
Yeah, when you were talking about your composite, I remember many years ago when I was playing with the F-16, and they had carbon composite tape and so on like that. But you kind of threw that out by using plant material, but that still leaves, how do you get the electrical system in the walls, kind of like you'd have in a normal house? And do you have a plan for how you're going to do the electrical system?
Yeah, we drill holes, thread it, and put the boxes and the conduit on the walls. Just
like regular house.
Just like a regular house. Yeah, yep. That's the reason why we actually, our executive vice president, Brian Kulinski, said, can we drill and tap this stuff? And it's like, we better be able to. So we did. We drilled and tapped it, and it works great. So yes. Now, when we're talking about like Station 520, this is not what the thickness of the walls are going to be. We're talking 3-meter walls. So we can drill holes and mount things without a problem. 3 meters should give us protection against micrometeors, the sun, radiation. In fact, that's the neat thing about this. I don't have to use just plant material. I can mix other things in here. So if I need a thin layer that has extra radiation protection, I could throw in, nanoparticles of lead in there, or I could throw in something else that has a high hydrogen content and mix it in. Now, it won't be necessarily be a structure part, but it could be another thing that slides over the whole thing.
Yeah, like Kevlar is supposed to be very good against radiation. So, yeah, I could understand that. And then we get to the real sticky thing of what do you do about Windows?
Who needs Windows? No, seriously. That's what cameras are for, and 60, 50,
Mhm.
80-inch TVs. I mean,
Mhm.
I'm sure everybody here has seen Space Odyssey, 2001 Space Odyssey.
Mhm.
The You had the point where he was sitting on the station on his phone call, and you could see the Earth rotating outside. Now,
Mhm.
I don't know about you all, but I'd start going, watching that thing spin around like that. So I envision we would have outside cameras, and inside we'd actually have large displays, and they would be stationary, so you wouldn't see the spin of the station.
Mhm.
Go ahead,
That's
John
all
Hunt.
smooth, Moet.
Yeah, is this thing going to be hollow or is it going to be like, it almost looks solid right now? So it's going to be hollow and have different layers and levels in it and so
Yes,
forth,
sir.
or
Yes, sir. It will be hollow. The skin will be about 3 meters thick, but we will have about 9 to 10 meters. Actually, I think we said 15 meters. Uh, so if I'm standing on the floor,
Mhm.
the width of the station will be, I have it in the paper, but I think we said 10 meters, something like that. So from side to
Hmm.
side. So, and then you can have different levels. You can have different levels in the station with varying types of gravity up to the center where you have no gravity at all. And when I
Hey,
say gravity, I
George.
mean the centrifugal force.
George, you mentioned earlier, and in the paper, that you envision starting with 7 Starship-sized vehicles,
Yes, sir.
and the initial 7 vehicles will be incorporated into that structure. This seems overly ambitious for a new process. Are there plans for a smaller pilot proof of concept orbital demonstration?
Hmm.
It seems like if you go big like that, you could run into a lot of issues unless you validated all your processes.
Right. So, as an example, our printer, proof of concept, prototype, fly the prototype in uh, um, suborbital flights, proof that is, then fly it in an orbital flight, and then fly the prototype outside the vehicle and see how it does. That's the steps we do there. The hydroponics and aquaponics start with something that's earth based, get the process down, shrink it down to it's something that we can fly it suborbitally, make sure the process works in short periods of microgravity, fly it orbitally for X amount of flights to proof it. But yes, everything has its steps. There's some steps that we're not going to be able to proof until we get there. The vehicles I'm talking about are going to have to be specially constructed vehicles because we want to be able to gut them as much as we can to get as much space to pressurize. So that means let's take the Starship, for example. We're not going to need heat shields. There's a lot of stuff. We're not going to need as large tanks because we're not going to be re-entering. So there's a lot of things that will change. It's we just reason why we say Starship size. Can we fly one of those before we actually depend on it? Sure, we could proof the vehicle and make sure it works. In fact, we may even be able to fly it up there, proof it, and leave it there for us to attach to later on. But yes, we are going to take it step by step and proof each step. It's the reason why right now we're in research mode for the material. This is the first step to the whole thing. We have to get the material right. That means we have to test it at different temperatures. We have to test it for durability in a space environment, the radiation, the everything. We have to get this right first. Now, in parallel, we are working on the printer because ultimately it's going to be 3D printed. So the best thing to do is to test this material that's been printed. But for right now, with the funding we have, we're doing the material first and then get it printed, get it proofed. Then we work on the growing it, the farm, and we proof that. And then we just keep growing, keep moving forward. Some of it can be done parallel. Some of it has to be done parallel. I mean, in serial.
Do you have plans for hypervelocity impact tests?
Um, what velocity are you thinking?
7 to 12 kilometers per second.
Yeah, I'd love to. Um, we are limited with what we're going to do. Right now, we're using 22s. We're at about 1,000 FPS. We're going to bump it up to a 556, which will give us about 3,000 FPS.
But if
But
you're
ultimately,
if you're 3 meters thick, it's going to be hard to
yeah,
break something.
right. But if I'm shooting something this thick, I get the characteristics of the material.
Right.
Like right now, we know that this particular mix at minus 80 C, when we shoot it, it shatters. That's not good. We've had other mixes with other materials that didn't shatter. Now, it didn't stop the bullet on this thickness. If you went 3 times this, it would stop the bullet. But we don't want them to shatter. It's fine if it goes through, but we don't need a lot of loss of material out of the back. So it has to maintain its integrity. So we can test it with what we have. Now, if we get something that passes at a 556, 3,000 feet per second, now that goes on to the next testing level. And yes, ultimately, I'd love to get a facility that has those capabilities to shoot this thing with a 10,000 FPS slug. Yes, I'd love to do that and see what happens.
AJ.
Yes, hi. What is the density of this material, and what would be the mass of this entire station that you are talking about, approximately? And the other thing is that if you want to build something 3 meters thick, 3 meters thick, and I think you've said 15 meters or 20 meters in diameter, something like that, you would have to take all that mass in plant up there somehow or the other, and I presume that's why you are talking about something like a starship, I suppose. That's probably possible. And the last question is, for making a 3D printing idea work, you will have to convert this into a dry particles or something like that. Is that right? And then you can do the 3D printing after that, where they'll coagulate and stick together.
Okay. All right. Let me start with your first question.
Mhm.
What's the density?
Yeah.
It varies. We're still trying to nail down the formula. That's the reason why we're doing testing. Depending on what we use the filler, the density can be very heavy to very light. This plant one is probably the
Mhm.
lightest. Do I have an exact density? No, we haven't measured exact densities on these.
Approximately.
I wouldn't even know where to. No, I can't even give you an approximate. It's light. Well, hang on.
Mhm.
Oh, here we go. Let's see. Yeah. This one was
Mhm.
done with over-the-counter epoxy, not the bio epoxy, just standard over-the-counter epoxy and basalt. It weighs about 4 times more than this because the basalt weighs so much more.
Mhm.
I could sit here and BS you all day about what the density is, but we've never measured it, never even tried to calculate it. It hasn't even been one of the questions we had until we know what it is, which leads into the second part of your question. How much will the
Mass.
station weigh? Until we know what the formula is and we know the density, we're not going to be able to calculate that. So that is one of the questions, because that also leads into what is it going to have to be the tensile strength, if it's being yanked on. So there's a lot of questions that that's the reason why I say we're in research here right now. That's
Sure.
what we're doing.
Mhm.
Let's see. So that was the first question. What was your second question? I'm sorry.
About the particulate coagulating and 3D printing. So it has
Right.
to be in a particle
Okay.
dust form.
No, it does not have to be in dry form. We print it wet, and we dry it as we print it. So if you've ever played with epoxy, you know it. There's a certain cure time in it. We've used both UV curing type epoxies and used UV light. We've also done heat accelerated epoxies. The printer, the initial printer, just to make sure we weren't being stupid, used both methods and it worked. Now, what we printed looked like garbage because the printer wasn't exactly working the way we wanted to, but that's beside the point. But no, it comes out as a wet slurry, a very thick wet slurry that holds its shape as we print, and then we dry it as we print.
Okay, thank you.
George, I remember reading your PDF, and you talked a lot about the need to figure out how to be Earth independent at some
Yes, sir.
and rather
Yes,
than
sir.
Earth dependent. So we've been talking heavy duty engineering because everyone here except me is an engineer, I think. Um, how are you going to get us to be Earth independent? And what are your plans for that? Because right now, everything is brought up from space, food, the waste is brought back, everything, although, that we're only dealing with the space station. But you're not doing any in situ work for your printing that I've heard you say. You're printing with materials on the ship that's sort of in situ, but not lunar in situ, for example. So spell it out.
Okay.
And do so.
All right. So I've already mentioned we're going to be using aquaponics and hydroponics. Aquaponics is nothing more than fish, and hydroponics is the growing plants in essentially water. So the fish fertilize the water fertilizes the plants put some material back in it, and it goes into the fish tank to feed the fish. Okay, we get a cycle there, but we're going to be pulling carbon and material out of it. How do we refresh that? One of the questions I was asked at ISDC was, how are you going to deal with if you're not the first out there? I don't want us to be the first out there. Every other station that goes up traditionally, where they build it on or build parts of it on the Earth, take it up to Earth, and then they resupply it from Earth, becomes our customer. Why has it become our customer? Because we can resupply the station cheaper than they can from getting supplied from Earth. What do we get from them? We get their waste, which we process through our aquaponics and hydroponics. What do they get in exchange? Oxygen, fresh water, uh, food. So that's how we start becoming independent. Does it happen overnight? No. There will have to be supply runs from Earth, but as the economy grows, as the orbital and Earth, Moon, Mars economy grows, it becomes more and more independent of Earth, where Earth only becomes a market, not the controlling factor of the whole thing.
Do you do any projections on growth and the economy? And if you do you put a CI next to those projections, or what do you do with your projections if you run them? I'm really curious.
I have not been I am not egotistical enough to try to say how much money can be made. I do have a paper that's in draft form that talks about how the economy starts, grows, and what it turns into. In other words, it's a theory economic paper. I'm going to submit it to ISDC for Los Angeles to see if they'll accept it and present it there. So I know the theory on how the economy will start, how it will grow, and the different steps it'll take. The amount of money, I'm sorry, I'm flabbergasted that we actually had our first trillionaire. I figured we were going to do that until we got into space. So no, my ego is not big enough for to say how much money we're going to make. I'm sorry. That I'll leave that to others to try to figure that one out.
Marshall, we'll leave it to you. What do you think?
Well, we will be surprised when someone really starts making money in space, because I think it's going to be something we don't expect. But my question really comes to is in your 3D printing head, it has a certain size. Are you chopping up the hemp fibers to a particular length to hold everything together? Or are you using some system kind of like laying down carbon fiber in an aircraft, where you glue it together and make it hold together because you've got much longer lengths of thread.
We actually, right now, currently, are chopping it up and printing it in that manner. The longest length we've used is a 1/4 inch, and it has to do with the size that we're printing. I mean, when we're talking, when we're talking this size, our heads only can be so big, and you have to be careful of jamming up and everything like that. So about a 1/4 inch.
Exactly.
What we found, what's interesting is as the pressure is applied, the fibers will actually align to go out the nozzle. So that's really cool. We also have a couple other plans on how we can add a longer fiber as we're printing for reinforcement. But no, we're not going to do it. We're not going to impregnate a cloth. That's not how we're doing it. This is all going to be in one pass printing, essentially.
The next corollary is in hemp plants, some of the fibers are real long, some of them are real short. And it's kind of like, oh, do you plan to do genetic engineering so the plant produces the length of fibers you're most interested in?
We'll be using both lengths. In fact, that's what we do right now. So out of hemp, you get a silk, which is the long, almost like hair fibers that you can actually weave and everything else. But you also get a wood pulp out of it. We grind the wood pulp into the size we want, and that's the primary filler. And then we cut the silk fibers to the 1/4 inch lengths and add that into it to help reinforce it.
Okay, interesting. Thank you.
Are you satisfied with launch costs for today on I guess a SpaceX vehicle is probably your only opportunity today. Are they low enough for you to do what you want to do, or are you hoping for miraculously lower launch costs, even lower than what Starship talks about? What are you looking at for launch costs?
Okay. I'm going to answer the question with a question. In 2005, when I was on the show originally, what was our launch costs then? And what are they now today?
Well, let's
What
put it
happened?
this way. No one could afford to launch me to space back then. Let's put it that way.
Yeah. So I expect launch costs, especially if we can get competition, if Blue Origin can actually work the problems out and we have competition going on, I expect launch costs to come down. Launch costs, back when I was part of SFO, we looked at what launch costs need to be to really make things explode. And we were looking at about $100 a kilogram. I think we're almost there or pretty close. I mean, honestly, yes, that's not what they're charging customers. But if you start looking at if Starship becomes fully reusable, and now you're getting down to your fuel costs are really what's driving the cost to orbit, we could hit $100 a kilogram. That would be great for us, but we'll deal with how it is at that time. The reason why I say that, our initial costs will be high. The initially putting up the stuff for Station 520, getting up and running, yes, we will have launch costs. That will be a really high initial cost. Once we're operational, once we start seeing an economy develop there, launch costs go down because we don't need the services as much. Eventually, the services that we'll be using for launch is when a customer wants to send something specifically to us to work with or whatever, and return costs if we're returning a product back to the Earth. We plan on making stuff for space, not for the Earth. Doesn't mean that other companies won't rent space that will do things where the product will go back to Earth. That's where their market is. Or they may make stuff where their market is the moon or Mars or the belt. Who knows? The idea is to provide manufacturing construction facility that can build what you need for whatever you're going to do. and then the possibilities become endless. What do you want to do in space? Do you need 1G? Do you need microgravity? Do you need a platform? Do you need a torus? Do you need a pie? What shape, what size do you want? We build it, and you do your thing in that.
Let me real quickly to Brian and Brian on the telephone. They're both named Brian. You're welcome to participate fully in the program. So if you have comments or questions, or you want to join in the discussion and conversation, just step in and talk. We'd love to hear from you. But just want to make sure you know that we welcome your full participation. So go for it. Regulatory world. Do you know if you face anything that's a deal killer, an apple cart turnover, something that's going to blindside you? Are you paying any attention to regulatory yet?
Funny you ask that. So back in 2006, 2007, I believe it was, we formed a company called Black Sky Training. We were the first company to get a space flight approval for a training course and eventually a training training school. We've dealt a lot with the FAA over the years. Not so much recently, but yes, we know how to walk in and deal with these people. Perfect example. One of the gentlemen that is on the phone, Brian Kuklinski, is a master CFI. We were going before the FAA to do a presentation because we wanted to get a certain type of approval that they've never done. We were going to do something really strange. When we were doing the presentation, I was going to have him do it because pilot talking to the FAA makes perfect sense. So we were working on the presentation. I said, okay, first slide, tell them what we want to do. I said, the next 3 slides are going to tell them what the regulations say that says that we can do what we want to do. And he's like, but they know the regulations. I said, it doesn't matter. So we're in a room. We have the FAA. We have the space side of the FAA. We have the aviation inside of the FAA. And we have the AG portion of the FAA all on the same table. And he starts up there. And initially, they're like, no, we had dealt enough with the space guys for a while that they knew not to say no. Just wait for the other shoe. We put up the regulations. The aviation guys are going, oh, and the lawyers are going, you can't do that. You can't do it. Says right here that, yes, we can. So we know how to deal with regulations. Yes, there will be gotchas along the way, without a doubt. We're going to be going into areas that the FAA has never, that the U.S. government has never even thought about. It's a dream to maybe NASA, but nobody else has dealt with it. So yes, we're going to have gotchas. We're going to have to work with the government, not work against them, but work with them and say, look, this is what we want to do. Here's what your regulations currently say. Do we run under the current regulations, or are we going to have to work with you in crafting new regulations so that we can do it and everybody feels good about this? Been there, done that. We'll do it again.
Okay. Are you starting that now, or it's premature?
It's premature. Part of the reason why I was excited about coming on your show is I know there's a lot of people who listen to your show, and the word will start spreading about what we're trying to do. Eventually, a lot of the people we worked with have retired out of the FAA. There's still a few there, but they'll eventually call me up and say, what are you guys doing now? And we'll eventually start working with them and start dealing with what's going on. But we're not ready to go knocking on doors because I don't know what to ask for yet. I mean, I'm not trying to fly anything yet. Everything's going to be ground tested first. Initial testing is going to be on existing vehicles. Until I get ready to float things outside the vehicle, I really am not going to have to go after the FAA approvals yet. We'll be talking to them long before we do that, but we're not there yet.
And with commercial LEO destination, there'll already be commercial space stations up, so you won't be plowing any new ground building a station.
I hope so. I hope so.
Do you have any theoretical competition?
Everything I have seen, and I do not like to say no because I don't know what all is out there. Everything that I have seen is some version of we build it on the ground, we launch it up, and we either launch it whole or we launch it in pieces and put it together, and everything goes from Earth to there and back. It's nothing, it doesn't start building anything for space. So I haven't seen any. Doesn't mean that there's not concepts out there. I mean, we've been doing this since 2004, 2024, and until recently, people really didn't hear about us because we weren't talking about it. So I don't know who else is out there that's not talking about it. I hope that if there is other groups out there that are talking about that and they have a concept that's similar or is complementary, that they would think about joining the IRN and having us work together as opposed to beating each other up.
Let me take you back to the beginning, before the beginning. So clearly you're well versed in engineering, and clearly you know your way around space, both real space and theoretical space. What's your background? How'd you fall in love with space development? Are you an academically trained engineer? Was this a pipe dream and you woke up and said, hey, we can do this with 3D printing? I mean,
Uh,
give us the backstory.
oh, so we're going to go there. Okay.
Yeah, we're going to go there.
So how did I fall in love with space? I saw some very brave men step off a Lego, or essentially a very flimsy vehicle onto a foreign body that was not the Earth. Watching our astronauts step on the moon, just, I don't know, something inside me clicked. Uh, the first time, yes, the first time I went to college, I was a mechanical engineer. I wanted to work for NASA really, really bad. I was going to college at UCF, University of Central Florida in Orlando. I got accepted for what they called the co-op program, essentially junior engineer. You work a semester and you go to school for a semester. I actually was in a part of the NASA solid rocket booster operations office. My office was in the VAB. You can't get any more space than that back then. I was out there on the platforms when we were stacking SRN segments. I rode out to the pad. I mean, I walked under the orbiter. It was space. I mean, at 18 years old, that was my dream. Unfortunately, I found out that NASA wasn't the NASA I was expecting. It was government. And at 18 years old, 19 years old, and government just we didn't mesh well. I mean, I was told that once I completed my degree, I was headed to Washington, D.C., and I was going to work on the space station. You know, what was it, Space Station Freedom or whatever it was called at the time.
Mhm.
And that's when I quit school, quit NASA, and I joined the Army, which is where I got my training in electronics. And I was in military intelligence, so the training I got in electronics was very extensive. I got out. I met some folks, Space Frontier Operations. They thought same way I did, that we were doing space wrong, that it should not be government that does it. It should be private. Government is good at R&D. Once it's developed, it should be moved into a private sector and let them turn it into a product. We worked on a lot of papers. It was a good think tank. I met a lot of guys that worked at NASA or worked out at the Cape. It was a good time for me. I learned a lot. I learned how to write. It was great. But they're a think tank. They're not going to do anything. They're not going to get their hands dirty. They're going to write papers, and that wasn't for me. So that's when I started doing hands-on stuff. That's when I did the trailer with 2 flight simulators, and we traveled to the United States. That's when we formed Black Sky Training. And of course, I believe somebody once said, how do you make a small fortune in space? You start out with a large fortune. Well,
Mhm.
I went from a decent fortune to zero, and did other things. And then been looking at 3D printing. I have Brian Nathan, our VP of engineering, is heavily into 3D printing. We were playing around with it, and quite literally, we were walking, the three of us, Brian Nathan, Brian Kulinski, and myself, were walking through a grocery store. We had been reading a DARPA paper or DARPA request for proposal where they were talking about growing stuff in space, growing a platform or station or whatever using crystal. And we were talking about it, and I believe it was Brian Kuklinski that said, "What happens if we use plants?" And we kind of laughed and chuckled a little bit, and then we started thinking about it. Basically, we feel that God put the seed in our brain and it germinated, and that's it. Just we said, I don't know, let's find out, and we started doing research, and it looked more and more possible, and suddenly it's like we're headed down this road at full speed. So yeah.
Hey, George, have you heard of Grow Mars?
No, I have not.
So it's headed by Daniel Tompkins, Tompkins, who's been on the space show before. And he's an agricultural scientist and the founder of Grow Mars. And he has what he calls an expanding loop concept for self-replicating greenhouses that would be 3D printed in situ, either on the moon, Mars, or in space. And so it's very similar to what you're doing, but he's utilizing sunlight and local resources like water and CO2 from human respiration to grow algae for food with byproducts of biopolymers as binders for 3D printing blocks from and I looked at his website and it doesn't seem to be active, but he may have fallen off the scene recently, but that's someone that you might want to collaborate with because he's definitely looking at the same stuff.
If he actually watches this, please get in contact with us. Go to our website, fill out a contact form. Yes, I would love to talk to somebody like that. Absolutely. If they're active, let us know.
I'll send you his contact information.
Oh, perfect. Yes, I would love
yeah.
to talk to him. Yes, that would be great.
What was your reaction from the people in the room at ISDC? Because that's a mixture of votes. So I'm curious to what was understood. Was there an interest? What can you say about your audience?
Well, so we were the last presentation, and due to unforeseen circumstances, our time got compressed. So we weren't able to do a full presentation the way we wanted to. However, since we were the last presentation, we were still standing there, and we had a lot of people come up and talk to us. In fact, that's how we ended up on the show. So ISDC, I've been to a lot of ISDCs. And I don't want to bash them too hard, but this past ISDC was less organized than the previous ones. However, for contact wise, it was a fantastic ISDC for us. There was the bar, yes, that's where a lot of business gets handled, was right there right in front of the main door. And just walking through, you start seeing people and you start talking, and it was great for the context. It was great for me to figure out that IRN was really something that needed to be done. We had a lot of interest. The people who had seen our presentation had talked to us. They talked to other people. We talked to other people. So yes, there was a lot of interest in what we're doing.
And you're going to present again in Los Angeles next year?
If my paper is accepted, I will be presenting on the economic impact of the first step.
Yeah, I'm sure your paper would be accepted. So I can't imagine if it would not be. Do you have a pat reply or a way of directly responding to someone who is beyond skeptical and challenges you?
I like challenges. In fact, to tell you how we do this, We just had a board member resign. He decided that he wanted to go do his own thing. He didn't want to leave us, but he didn't want to contribute as much time he's been doing to us. So he resigned his board position. So we were looking for a new board member. We decided that we were going to go outside of our comfort zone and bring in people who were not necessarily part of what we've been doing all these years. We wanted new blood because we need people to challenge us, to challenge some of our assumptions, to make us think. So if somebody is out there who's very skeptical about what we're doing, yes, I'd be more than happy to talk to them. I'd love to talk to them because they'll make me think and they'll show me where the holes are in our whole theory.
So you welcome the challenge.
Oh, absolutely. Because it's not a challenge, it's learning. In reality, I mean, new ideas, new thoughts, that's how you learn. That's how you find it's how you find out what you don't know. Because you don't know what you don't know.
John Hunt has another question for you. We can't hear
You're
you,
muted, John.
You're
You're
muted.
muted.
Oops.
It's always
I have trouble visualizing this a little bit. Okay, you're going to make all this stuff, but how are you going to put this together? I mean, you're going to actually build the fundamental outside of this structure first, hollow, and then start building levels inside of it, or how would that actually be put together?
All right, so imagine what do you call it? We build a frame with tubing essentially. So consider like you're building a frame for paper mache.
Okay.
And then we start sheeting it with the material to seal up the outside. And then we can start building the levels on the inside. You're putting in the floors, putting in electric, that kind of stuff. Yeah. But the initial part of why we need so many starships to start with, or starship size vehicles, is that some of that we'll be carrying is the material we'll be making frame, the metal frame to start with. Future development, future stations won't be done that way. Future stations will print the beams, print the frame to start with, and then sheet it with sheets of the material.
That brings up an interesting point. In Burt Rutan's aircraft, he basically used a big frame and blew fiberglass into it to get just about any shape he wanted. And your system kind of does the same thing, but you don't need to have a cast to put it in to a certain degree. And it's kind of like, do you have a casting system that you could cast certain parts that need to have certain characteristics through 3D printing, or is there any casting required in the whole system?
The answer is we're not sure. As it is now, our way we're looking at things, everything can be 3D printed. Now, we'll have more than one printer. We'll have the big printer that can do up to 50 meters in diameter, but we will have a couple smaller printers that can do special curves and that kind of stuff that would be operating inside the framework and all that stuff. Would we end up having to cast anything? I don't know. That's the reason why I would need to hire real mechanical engineers to design the whole station to tell me where the complicated curved sections are that we're going to have hard time 3D printing. However, with everything I'm watching in the industry with additive manufacturing right now, that's the way you do complex curves, is through 3D printing. So I don't see where we'll have to cast anything. The only reason why we're using a metal frame to start with is that's the easiest thing to ship from Earth to space and put together to build out this framework. After we get the Station 520 working, the framework would be made, by the way, we call it Stellimer, the material It's called Stellar.
Mm-hmm.
We would build beams, and the framework would be made out of Stellar and put together, and then it would be sheeted with more Stellar.
Oh,
Hey,
okay.
George, does the 3D printer can it operate in vacuum, or do you need an atmosphere?
Nope, it's designed. We actually have a patent pending. It's designed to work in vacuum. In fact, the full size printer, this is what's on Station 520 is only about a half size printer. The full size printer is supposed to be standalone, not part of a station, and it should be able to do things that are 100 meters in diameter. So it would be fed by a station. The material it needs to run would be fed to it, but it would not be enclosed or be a part of the station.
Mm-hmm.
It would be a standalone. The
Mhm.
520, the Station 520 has the printer built into the center. It looks like a little cup in our diagrams. And that's just for convenience sake. We needed to have a way to start things. And that was the easiest way to figure out how to start things.
And so you don't need gravity. You can do it in zero G.
Yes, sir. Absolutely. I don't know if you've ever played with 3D printing, but if you adjust your nozzle right, you can have it so that it can come down and apply. So as it extrudes the material, it's pressured into what you're printing on. And that's how you make a good seal as it goes around. So you can, or this way or whatever. So no, the pressure coming out of the nozzle would put the material where it needs to go, and then the heaters and UV lights would essentially cure it in place at that point. Now, not saying it's going to look pretty. In fact, you see, y'all, I'm sure have seen the cement houses that they're making now, 3D printed cement houses. Yeah, that's kind of the way it's going to look. Is it's kind of like that, and they do the same thing. They extrude out of their nozzle, and there's actually pressure coming out. It doesn't use gravity to actually fall onto the layer before. There's pressure coming out of the nozzle that actually pushes it onto the layer below it.
That brings up the error in my previous question. It's really what kind of surface texture can you get with your 3D printing? Because the center, yeah, that's fairly easy, but you might want a smooth surface, and that's why you'd have a form in place to give it a smooth surface. And then if you don't have the smooth surface, what do you do to smooth it up?
So what? You want luxury too?
Why not?
On the inside of the station, we could actually have spray guns where we could spray and smooth it out that way. I mean, there's a half dozen ways you could do it to fill in the bumps and the everything else. And what you would do is you'd use a different formula. You'd have less plant material and more resin so that it has a smoother texture than what you would get normally. So that is possible. It's quite possible that we'll essentially make panels that we would screw to the wall like you do with wallboard to give the smooth texture. So yes, there is ways that we can make it smoothed out, but that is not the main construction part.
Yeah, that you're really concerned with.
Right. Yeah. And it's the same way with electric. I was asked earlier how we put the electric in the walls. We're not going to put them in the walls. It's an industrial complex. It's going to be conduit on the outside, or hopefully at some point it'll be stellar conduit, not metal, not plastic, but actually stellar conduit that we glue to the wall and run wires through.
Have you given Go ahead.
No, I was just going to say the whole point is to have as little as possible shipped from the Earth. Now, when we get processing on the moon, where we can process metals and all that stuff on the moon, absolutely great place. We can buy that stuff and use it in what we're doing.
Have you given any thought to the human crew size on your vehicle?
No, sir. That's part of, again, step by step. First thing is we have to get the material working. Then we have to get the printer working. Once we have the printer working, we have a better idea of how much labor that's going to take. Once we have the farm working, we'll have a better idea of how much farm we want. Our idea is to have as much robotics as possible. That means when we're sheeting the outside, I don't want humans in spacesuits trying to put these sheets in place. Yes, there'll be a human out there supervising, but I want robots that are actually doing this. Same way with the farming. I want to have as much robotics as we can on the farming. So to answer the question, no, I don't know what size crew. The crew requirements will probably be driven by our customers. If we have spare space on 520, we will lease it out to our customers, and then however many people they have. But our operations, I don't know yet.
Guys, we're close to 8:15, moving close to 90 minutes. So you ought to start thinking about your final comment or two. Several have already retired. They're over on the East Coast, so I guess it's a little bit past their bedtimes. We're getting close to that time. So this is a good chance for you to come up with any sort of concluding thoughts or comments or suggestions about what you have been listening to tonight and what you think of it. And are you at all in touch with any of the teams doing the private space stations, the 4 or 5 different companies?
Personally, no. I'd love to talk to these guys. Up to this point, we were easily ignored. At this point, I'm hoping that they'll decide that we are worth the time to talk to, that we may be able to contribute stuff to their doing, because what they're doing is important to us. I want to see them succeed. They're our future customers, so I want them to succeed.
Mhm.
Do you
So,
go ahead?
yeah, a different question. You mentioned earlier your Interplanetary Regen Network,
Yes, sir.
and your partnership with Exo Scientific. They also presented at ISDC. I'm assuming that's where you met them.
Yes,
Um,
sir.
they have an aquatic life cultivation system, and that could be used for your closed loop life support, right? Is that the plan, that they would provide that service for the station?
I cannot comment on that. I'm sorry. I'm under a certain NDA. ExoSci is a member of the IRN, and they would be part of Station 520, supplying much needed services on the station. We are collaborating with them right now on developing some of those services.
Okay. Well, yeah, their website is available. I can, I go on their website and it looks like that's what they do, but I won't pressure you anymore on that. But that would be a very, shall we say, beneficial relationship to have with them. So,
Absolutely.
yeah.
John Parks is an amazing man, very intelligent. Uh, he knows a lot about, yeah, he knows a lot. He would probably be one of those guys that you could have on the show that could talk about regeneration and all that stuff. But yes, we had quite a few conversations at ISTC, and that's how we decided that we were going to partner together and actually work on a regenerative life support system and start IRN together.
John, you were at his talk at ISDC. So do you remember a question or a comment that you found interesting that we have not thought about on this show that might be worth bringing up in the concluding comment section? Maybe an ISDC participant thought of something that we should have thought of.
Nothing comes to mind. It was just my questions about, how this material is going to create the structure and how it all fits together. I I'm trying to envision, a space farm up there producing all the material, and it's, there's a lot of development that needs to go into that ahead of time. Like you say, you have to do it step by step. So what I didn't see, and the reason I asked my question earlier was on, you mentioned that you're going to be doing some prototype work and some initial steps, and those weren't shown in your roadmap. So that would be helpful to see, what these next steps are going to be.
I agree. And the presentation, we didn't have a lot of time to go through all that. But yes, you're right. A roadmap, uh, sharing our roadmap would be very good. Absolutely. I can't disagree with that. And one of the things that we're doing right now is we are redoing the business plan. And within the business plan will be the roadmap. Once we get that to a point where people that other than us can understand it, it's not in our language, it's in a normal language, we don't have a problem with publishing it on our website. But right now, our roadmap, we understand. We know what the steps are, and we understand we have it in writing. We understand what it says. If I were to give it to you right now, you'd look at it and go, these people are insane. This makes no sense. So we have to get it into a point where people who are not intimately involved in it are not going to will understand it, and that's part of the process we're going through, because we're needed for the new business plan, and that will come out. And in fact, it's possible. One of the reasons why we're redoing the business plan again is I want us to enter in the business plan competition at ISDC, and maybe that will be part of the. If we are in the top three, that may be part of the presentation where we actually list out our roadmap so that people understand what we're trying to do.
I think you have a good business case for that competition, and I think you could win it.
That would be nice.
Let us know if you enter it and if you are going to speak at ISDC next year. Health wise and everything willing, I will be there. Look forward to meeting you in person.
I would love that, sir.
And
Sit down and have
a
adult beverage or a soda, whatever.
water.
And yeah, water. I am right there with you.
Lunar water.
But yeah, I'd love to.
There was a lunar drink, about 20 years ago that someone was pushing. I don't remember the details, but I did a couple of space shows about it. They had a hard time getting shelf space in the supermarkets to market it. Does anybody remember that story? Because I should look into it. It really wasn't a drink from the moon, but it was something about, oh, I know what it was. It was enzymes that flew to space on suborbital rockets out of New Mexico, on that suborbital rocket thing that was being done in New Mexico 15, 20 years ago, 10, 15 years ago. And then from that, those enzymes, I think they were making beer and water. And they had a really hard time getting shelf space in supermarkets. Because for those who don't know, getting shelf space for your product in a supermarket's really political. And often the distributors are paying off the markets. And I mean, it's in tight supply. And so, but what they would do is they would bring I don't think they brought the beer. I don't remember, but I don't drink beer. But I think they brought the water that had the enzymes from space, from the suborbital flights, and they would give it away at space conferences. So I remember the SmallSat conference in Utah had a lot of the water being given away as a promotion by the companies. So, that was the origin of that, but I don't think it was anything really from space, but I guess you could maybe market your plants, sprigs from your plants from space to grow on Earth. Might be a side market that if the plants grew, I don't know, might be.
We're actually looking at something similar to that. Again, this is something we're doing with exercise, so I can't go into it. But yes, there is plans of having stuff that we grow in space and sold on Earth as a novelty item.
Interesting.
You mentioned the lunar regolith jewelry. I remember that whole thing about going and getting regolith and turning into
Turning it
jewelry.
into, yeah, jewelry as curio stuff and stuff like that.
Yeah, I
It
remember
never
that.
happened. I mean, there are thousands of reasons, but Dallas and I were part of that. And it was really meant to fail. But at that time, you could not get a private ride rocket to take you to the moon.
Yep.
And so everything was premised, including Musk. He started SpaceX because he could not buy a rocket, even a Russian rocket, that he could use to go to the moon with his Mars Oasis program. So he figured the only way he could have a rocket to go to Mars was to build his own rocket. And that was the start, way back when, of forming SpaceX. And the lunar people that Dallas and I were with, they thought they could buy access to the moon on like a government rocket that was going to the moon, but none of that is available back then for commercial users. And I don't know that a government rocket is available to commercial users for private business right now. So I don't know. I mean, you could probably buy a Falcon Heavy or something like that if you wanted to. But if it was a dedicated flight for NASA going to the moon, I don't know that you could buy a ride or a return from a government flight for your private trinkets from picking up regolith. I bet that hasn't changed much.
Well, look at all the trouble they had just flying tourists to Mir. Now, it was basically the Russians that said, yes, you will allow this. We will be flying tourists to Mir space station.
Yeah, but you couldn't you couldn't get a Russian ride to the moon to go gather regolith and
No.
get back. And back then, all the regolith and the rocks, remember, were top secret, government held property. So to even think that you were gonna go up and get a scoop of regolith and market costume jewelry was a pretty big reach. But they probably could have made money for a while. Then the novelty would have worn off. Could
Yeah.
they could they have covered the cost of launch costs back then? I seriously doubt it. Because launch costs back then were astronomically high, and you needed to return the product to Earth.
Yep.
So you had to go get it. So you needed a round trip. Anyway, if anybody has a closing comment, we're down to 90 minutes. Or George, if you have a closing comment you want to leave us with,
Well, I hope that I hope that I came off as somewhat intelligent and not fully insane. Uh, I hope that I made you guys think of something different, something new, that you see that we have an idea that we are proceeding with that has a potential of changing the world. I mean, if this really works and we really build a true space economy, the world will not be the same again. Now, what that'll look like, I have no idea. I'm an Expanse fan. I love watching the show Expanse. So, I don't know. I honestly don't know what it's going to look like, but I'm hoping at least I made you think about something new.
Thank you. And
Hey, George,
remember that we are a 501c3 nonprofit. If you like our programming, we really appreciate your financial support, like all these great people here who have been on this show. PayPal is on our website, thespaceshow.com, in the upper right corner. That is a very easy way to support us. And if you're a Substack user, they have their own program and method for fundraising. So you can do it through, I think it's Stripe, through Substack, or you can just click on our website, spaceshow.com, and gift us through PayPal. But we do ask for your support. We hope you will give it to us. And we do thank you very much for that support. George, and until the next time, we wish you lots of luck with your work and your development. And I want to thank John Jossy for being a terrific co-host, for Marshall and John Hunt and Phil, and our telephone callers, and AJ and Dallas, who left early for East Coast time. Everybody have a great week. As we like to say on the Space Show, keep looking up. And once again, thank all of you for being here tonight. Going 1, 2, 3. Any final comments? Good night, everyone, from the Space Show.